looks like this. It has a horizontal asymptote along the x-axis. Now, you could literally look at this as y is equal to 3x plus 0, right? And what happens is, if I asked you for the y-intercept, you would say that you would let x equal 0, and then you would get your value. So you get y is equal to 3 to the 0 plus 0, which gives us just 1. So we have our intercept of 1. And then, you know, your graph literally just does this. Okay, as long as the b value, this part, is greater than 0, it looks like this, right? So let's say I had y is equal to, let's have another one. Let's say we go and draw y is equal to 1/3 x. 1/3 raised to the x. So what that does is it actually just flips our graph around, and it looks almost identical. It's just reflected in the y-axis. And the reason for that is because we can write 1/3 as 3 to the negative 1, and then you use power of a power to get 3 to the negative x, which really means it's a reflection in the y-axis. So the negative x means reflection in the y-axis. Now, one of the things that you guys had some issues with was dealing with a thing called the inverse. So let's quickly go over that. When we talk about the inverse of any function, the inverse of any function is directly related to the line y is equal to x. Now, if I wanted the inverse of this one, if I wanted the inverse, y inverse of 3 to the x, you would have log base 3 of x. And all we're doing is we're just swapping. All we literally did was just swap the x's and y's. So what happens is we actually reflect everything for our graph of y is equal to 3 to the x in the y equals x line. So my graph looks a lot like this. So instead of 0, 1 here, now I've got an x-intercept of 1, 0. And then instead of having a horizontal asymptote going along here, this time we're going to have a vertical asymptote instead. And then when we draw this beautiful graph, we start from down here and come up here and kind of do that. Okay. Now, let's say that I asked you for the inverse of this one here. Remember, your basic equation for this is actually, for the green one, is y is equal to 3 to the negative x, okay? Or it would look like 1/3 to the x. Now, you can write the inverse of this as y. You know what? Let's write that in red. It would be y inverse is equal to the log base of 1/3 of x. So we still have our intercept of 0, 1, but then when we graph our new one, it's going to be 1, 0. And then our graph is going to look a lot like this. And you'll notice that I have a point here. That point doesn't change for both graphs. Okay. All right, so just think about what I just did. All I did was graph my lines, and then when I did my inverse, all I did was take some key points and flip the graph around. That's all I did. Now, let's go and talk about some stuff, some basic log principles. So let's say I have 3 squared is equal to 3 to the x. You would know that x is just equal to 2 in that case, because we literally just dropped the base. All right. So the next thing that I would like to look at is this. Let's say I have an equation of stuff. So let's say I have 2 to the x plus 3 plus 2 to the x plus 2 to the, let's write that as 2 to the x minus 1 times 2 to the x is equal to, let's make it 64. I don't know, 64. So in order to solve a problem like this, you actually have to factor out a 2 to the x, because each of these really means 2 to the x times 2 to the 3 plus 2 to the x times 2 to the minus 1 plus 2 to the x is equal to 64. So what you end up doing is you have to do your common factoring. So you got 2 cubed plus 2 to the negative 1 plus 1 is equal to 64. The next thing that you have to do for a problem like this is you have to punch that into your calculator. So you've got 8 plus 1/2 plus 1 is 2 to the x, which is equal to 64. So now you've got 64 is equal to 8 but 9.5 is 2 to the x times this. So now to get 2 to the x by itself, we have to divide both sides not by 2, but by 9.5. Whatever was in that bracket. Alexa, 64 divided by 9.5.
64 divided by 9.5 is approximately 6.7368.
So 2 to the x is equal to 64 divided by 9.5. And then to solve for x, now you go and do your log rules. You say x is equal to the log base 2 of 64 divided by 9.5, which really means the log of 2 base 64 minus the log of 9.5. And there is your answer, right? So these type of problems you're going to see on your test, right? I can't give you everything, but I can give you quite a few. Now, the last thing that I want you to recall is this. Let's say that I give you a bunch of things like this. Log of, let's go 2x plus 1 minus 3x plus 4 plus log of, let's say, x plus 3. If I asked you to simplify this log, you would literally have something like this. You start by bringing all your exponents into your brackets. Minus log of x plus 4 cubed plus log of x plus 3. And then to bring it into one nice logarithm, you write it as log with a big bracket, and there will be a top bracket and a bottom bracket. Anything that has a plus in front of it, like these two, will be on the top part of our bracket. So you could write this as the log of x plus 1 squared times the x plus 3 divided by everything in red, everything that is minused. And so you've got minus x plus 4 cubed, and that would go on the bottom of our fraction where we'd have x plus 4 all cubed.